This is RD Sharma's solution, class 12, chapter 12, higher order derivatives, MCQ, multiple choice questions we are taking. If we have x is equal to a cos nt minus b sin nt, then d2x by dt square we have to find out. So there are four options, one will be correct, and these kind of questions we have already did. So let us do it. It's simply just a differentiation, but there is no dy by dx here. It's actually d2x by dt square. So x is equal to a cos nt minus b sin nt dx by dt. A cos nt is minus sin nt. Then the differentiation of nt will be n. Minus b sin t will be cos nt. Differentiation of nt will be n. This is dx by dt. So d2x by dt square. So minus a, so minus an was already there, sin nt is cos nt, so there will be again an n, so n square will be there. Here we have cos nt will give you minus sin nt, so I have made this negative as plus, again cos nt, sin nt, then n will come, so we have bn square. Okay, I am taking negative outside here because I need this a cos nt minus b sin nt somewhere. So if I take minus n square outside, it will be a cos nt, and here if you take this already we have taken outside n square, so it will be b sin nt. So what is this? As I said, when you take minus n square, the inside thing will be nothing but x. So d2x by dt square is nothing but negative n square x. This is how you are going to write actually. So these wordings also to be followed. X is equal to at square, y is equal to 2at, then d2y by dx2 we have to compute. So we have just completed this in previous discussion, but we'll try to do it again. X is equal to at square, dx by dt is equal to a, so t square will be 2t, so 2at. Y is equal to 2at, dy by dt is equal to 2a only. We need dy by dx, so dy by dx is nothing but dy by dt divided by dx by dt. So just divide these two. 2a by 2at is 1 by t. So this is 1 by t, but this is just dy by dx. We have to compute d2y by dx2, so you have to differentiate this again. 1 by t is going to be equal to negative 1 by t square. You know already about this differentiation. But we are not going to stop here because we are differentiating with respect to x, not with respect to t. So you have to introduce dt by dx also. Dx by dt is already with us, so we have the reciprocal of 2at and multiply minus 1 by t square into 1 by 2at. So this t and t square will give you t cube minus 1 by 2at cube. This is the option you are going to choose for d2y by dx2. Four options, one will be correct. Y is equal to a x to the power n plus 1 plus b x to the power minus n, then x square into d2y by dx2. This question in 12.2 exercise of higher order derivative have already been done, but for the sake of completion, let us do it quickly. Y is equal to a x to the power n plus 1 plus b x to the power minus n, dy by dx is equal to a, see, x to the power n differentiation is nx to the power n minus 1, so you have to follow it wherever x is there. So it will be n plus 1 x to the power n plus 1 minus 1. So this will be x to the power n only. Now you know already that negative is going to come, so I am just putting it negative here. B, this x to the power minus 1 is minus n x to the power minus n minus 1. So negative has already come. So this is just dy by dx. We are going to compute d2y by dx2. So d2y by dx2 is going to be a n plus 1, and this already I showed you, it is nx to the power n minus 1. Now minus b n, this comes in front, so minus n plus 1, and minus n minus 1 minus 1, so minus n minus 2 it will be. So this what you can do is a n plus 1 x to the power n minus 1, and then minus b minus I am taking just outside, so I am making it plus b n plus 1 x to the power minus n minus 2. So d2y by dx2 you have to multiply it by x square, so just multiply it by x square. So x, the power can be added 2 and n plus n minus 1, you have to add 2 plus n minus 1 is simply n plus 1. So you have a, see, n plus 1. So we already have ax to the power n plus 1 in y. So we actually are eyeing upon getting y again. So what I am trying to do here is, we know that ax to the power n plus 1 is already there. So whatever is left, just take it outside, right? Just take it outside. Here also, you have to add this 2 plus minus n minus 2. So you have x to the power minus n, which was with b when we started with y. Now n plus 1 you can take just outside, and whatever is inside just write it ax to the power n plus 1 and plus bx to the power minus n, and this is nothing but y only. So you get n plus 1 into y. This is your x square into d2y by dx2. This is your answer, n plus 1 into y. So there may be some misprinting, but you know how to get the answer. Okay, if you want to do it directly, this kind of question, it's d raised 20 or d20 by dx20. So you have to differentiate it 20 times. Well, that won't be possible for us to do. It is possible, nothing is impossible, but there has to be some trick. What is the trick here? The trigonometric identity and equation will come handy in this. First, this 2 cos x cos 3x. So 2 cos a cos b is nothing but cos b minus a plus cos b plus a. This you already know. Alright. So just remember, cos a minus b plus cos a plus b is nothing but 2 cos a cos b. So that is what we are going to apply here. 2 cos x cos 3x can be written as cos 3x minus x plus cos 3x plus x. So the multiplication thing we have converted it into the addition thing. So we will take it to 1, 2, 3 level, and then we'll try to find out a pattern, and depending upon or according to that pattern, we can finally get the final solution, general solution you can say. So cos 3x minus x is cos 2x, cos 3x plus 4 is cos 4x. So we are differentiating it. Cos 2x is minus sin 2x, and we have 2x differentiation is 2. Here also cos 4x is minus sin 4x, then you have a 4. So just taking minus here. Okay. Now just take minus 2 outside. So this is the odd differentiation, first differentiation. So minus 2 I have taken out, and then sin 2x plus 2 sin 4x, then d2y by dx2. This is the even differentiation, d2y by dx2. So minus 2 was already outside, sin 2x was cos 2x, 2 will also come here because differentiation is 2x is 2. Then sin 4x is cos 4x, then differentiation of 4x is 4. Now just take 2 again outside. So you have minus 2 here, 2 taken out. What is inside? Cos 2x plus 4 cos 4x. Now this is an even differentiation. Now remember that d20 by dx20 is an even differentiation. So this is going to come. We just need to know what this 2 square or something will come. So we have written this as minus 2 square, and inside also we have done the 4 has written as 2 square. So now again differentiating, cos 2x is minus sin 2x, 2 will come in front, then plus this 2 square. I'm taking minus because cos is minus sin 4x, and then 4 will also come. So this minus 2 square is already outside. Now take this negative outside. This is a odd differentiation. d3 y by dx3 is an odd differentiation. So minus 2 cube. Now you are able to see the pattern now. Okay. So 2 cube. Then we have 2 sin 2x. This 2 we have taken outside. So only 2 will remain. So it will be 2 cube sin 4x. So I'm not doing d4y by dx4, since already we know the even and odd differentiation has given us a proper pattern here. Alright. So just do one more differentiation if you want, just to give an idea to the examiner that you know what and how to get the pattern out of it. This is the first differentiation. This is the second differentiation, and we need the second and fourth differentiation to draw the pattern. The third one was this one. So you just have to take the second differentiation or fourth differentiation and just see what is the power. Alright. So whenever we're differentiating, when we have d3y by dx3, it is minus 2 cube or 2 cube to be more precise. And inside also on the second term we have 2 cube. So when we do d raised 20 by dx20, it will be 2 to the power 20, and the even was d2y by dx2. What was there? It was cos 2x plus cos 4x inside. Alright. So this cos 2 to the power 20, cos 2x plus 2 to the power 20, right? 2 to the power 20. So this is the answer. Your second option is correct. This is just a pattern kind of question, but the trigonometric identity is very important. Now, x is t square, y is equal to t cube, dx by dt is equal to 2t, dy by dt is equal to 3t square. Now, dy by dx is nothing but dy by dt divided by dx by dt. So take dy by dt, divide it with dx by dt, you will get 3t by 2. So you will be tempted that, oh, fourth option is correct and we have got the answer. No, d2y by dx2 has to be done. So 3 by 2. Now dt by dx, because t is there, so dt by dx also has to be there, dt by dx. So d2y by dx2, 3 by 2 dt by dx, and dt by dx is nothing but the reciprocal of dx by dt. Dx by dt is 2t. So 3 by 2 into 1 by 2t, this is 3 by 4t. This is your d2y by dx2. This is your answer. The B option is correct. Y is equal to a plus bx square. So there are 4 equations. Which equation you are going to get? Just differentiate and try to get y equals to a plus bx square, or say y1 or y or y1, wherever it is possible. So y is equal to a plus bx square. Dy by dx is simply, you can write it as y prime or y1. So dy by dx is a 0 because it is a constant. B x square is 2x. So you get 2bx. Dy by dx is 2bx. Then we have this, you can call it as y1 or y1, y prime. So y2 d2y by dx2, y prime is 2b. Now y double prime, y2 is 2b. Let us multiply both sides by x, because we know that y1 is nothing but 2bx. So we are multiplying both sides by x. So x into y2 is equal to 2bx. It is y1 only. So x y2 is equal to y1. So you can write it as x d2y by dx2 is equal to y. Alright. So this is your option. You can just choose this option here. Okay, this question is a complex number question. It is a complex question actually if you are aware of De Moivre theorem, because it is cos x plus I sin x. Cos x plus I sin x is a relation or an equation which says that since we have a I there, that means it is a complex equation. So if you are not aware of De Moivre equation or theorem, it will be difficult for you to attempt this. So for that, to make it easier for you, I am showing you De Moivre theorem. So z equal to r cos theta plus I sin theta. When we do z to the power n, it will be r to the power n cos theta plus I sin theta to the power n. Alright. So this n will come with theta. That is z to the power n, r to the power n. Cos theta plus I sin theta will be to the power n, the n will come with theta. Now question is also saying f1 is 1 and f double dash 1 we have to compute. So this is the reference, because if those who have understood to apply the De Moivre's theorem, you can just go ahead and we will start with the solution. Fx, I'm just writing it in short. Fx is cos theta plus I sin theta, and then we have cos 2x plus I sin 2x, theta x we are interchangeably using, and the last one will be cos x plus I sin x. So since we know this cos 2x plus I sin 2x by De Moivre theorem can be taken as the power of cos theta plus I sin theta. Essentially all will be cos theta plus I sin theta with the power which is there with theta, or in front of theta, or in front of x in this case. So cos x plus I sin x, this can be written as cos x plus I sin x to the power 2. This goes up to cos x plus I sin x to the power n. This is De Moivre theorem. So these bases are all same. So we can add the powers. 1 plus 2 plus 3 plus till n. So cos plus I sin and to the power 1 plus 2 till n, and 1 plus 2 plus 3 plus n is nothing but n plus 1 by 2. You know already that this is an arithmetic progression equation, and we already know this is n plus 1 by 2. So what do we get? Cos x plus I sin x to the power n plus 1 by 2. Let us write it as, say, a. So we are writing it as a. A is n plus 1 by 2. So this is essentially equal to cos ax plus I sin x, because by De Moivre theorem this goes in front of theta. So here we have x. So we have this a goes in front of theta. F1 is what? Cos a plus I sin a. Remember, F1 is equal to 1 here. F1 is 1 here. So cos a plus I sin a is equal to 1. And this has to be kept in mind because we are going to use it in a short while. F dash x now differentiated. Cos ax is minus sin ax plus I sin ax is cos ax, and both the terms this ax differentiation will come. So we have minus a sin ax minus I cos ax into a. So you can take this a as outside. A was already outside, so we are taking a outside. So this is going to be a minus a sin x. This is f dash x only. In f double dash x, then you will get one more differentiation. So f double dash x, a here you have sin ax will be cos ax with a negative sign, cos ax will be minus sin ax, and then again a will come, I will be there. So we have this a taking outside, a square minus a square you take, and a, remember, it is n plus 1 by 2, nothing else. Cos ax plus I sin ax it is. This is f double dash x. Now this f double dash x, we have to compute f double dash 1. The question is asking about f double dash 1. And we already have minus a square cos ax plus I sin ax. So in place of a square, I am replacing a by n plus 1 by 2 because a was n plus 1 by 2 only. So we have minus n plus 1 by 2 cos a plus I sin a. But when you put 1 in place of cos a plus I sin a, we have already seen that it is f1. f1 was cos a plus I sin a, and it was essentially equal to 1. So this second term, a cos a plus I sin a, is nothing but 1 from the equation 2 in this case if you see to the left. Alright. So f double dash 1 is nothing but minus n plus 1 by 2 whole square into cos a plus I sin a. Cos a plus I sin a is 1. So you are just left with minus n plus 1 by 2 whole square. F double dash 1 is n plus 1 by 2 whole square. So now there are certain options in your answer, and you can choose the option as minus n plus 1 by 2 whole square. Please remember, this first differentiation result is used here because cos a plus I sin a was 1. We have already computed and we utilized it in the f double dash 1. If y is equal to a sin mx plus b cos mx, then d2y by dx2 is equal to. So y is equal to a sin x, and then we have b cos. So the angle here is mx. dy by dx we are going to take. See, this y is going to be repeated. So whenever we differentiate, we will try to get this y again. So dy by dx is a. Sin mx is cos mx, and differentiation of mx is m. Cos will be minus, so I am writing minus sin mx. Then you have b and then m. Then we have d2y by dx2. This is equal to am. Cos mx will be minus sin mx. Again, one more m will come. It will be m square. Then we have bm. Sin mx will be cos mx. Again, m will come. So m square will be there. So what we will do here is we will take negative m square outside. That is common. When you take minus m square outside, it will be a sin mx, because negative we have taken. So a sin mx plus b cos mx will be inside. So what is this? This is nothing but y. So we have d2y by dx2 is equal to negative m square y. So this is your solution. And there are 4 options. So what you have to choose is the first one, and you have to write like this. Fx is equal to sin inverse x by under root 1 minus x square. So I'll just try to change or suggest a change here in the question being asked, because it is f double dash x. It will not be double dash, that is there will not be double or higher order derivative. It will just be one derivative. So 1 minus x square into f dash x minus x fx. Fx is equal to sin inverse x divided by under root 1 minus x square. So when you take this fx, there are 2 ways you can do. Either you can use the p by q form or the quotient rule, or you can take sin inverse as first and then under root 1 minus x square, 1 by under root 1 minus x square as the second one. Or the better way is to multiply both sides by under root 1 minus x square. So you will get under root 1 minus x square into fx is equal to sin inverse x. Now you can apply a product rule here in the form of p dot q. So under root 1 minus x square, differentiation of fx is f dash x. Then you have fx, and differentiation of under root 1 minus x square you already know is going to be negative x by under root 1 minus x square, that we have already done in the previous discussions. So d by dx of under root 1 minus x square is this one, negative x by under root 1 minus x square. Alright, and this is equal to 1 by under root 1 minus x square. Why we have done this? Because sin inverse x differentiation is 1 by under root 1 minus x square. Now multiply everything by under root 1 minus x square, you will get 1 minus x square f dash x. You have, when you multiply this, you are going to get x fx. When you cancel this, it is going to be 1. So the question being asked is 1 minus x square into f dash x minus x fx is 1. So the answer here is 1. So the question, I have told you what should be the right question. Y is equal to tan inverse of this plus tan inverse of this, then d2y by dx2. So tan inverse a plus tan inverse b formula we are going to employ. So if you know this, you can do it by yourself. There is just simple differentiation which we already know. So there is log e by x square, and in denominator you have log e into x square. So log e by x square. Log a by b is what? Log a by b is log A minus log B, and log A into B is log A plus log B. This we already know. So log E by log, so log A by B is log A minus B. So log A B, that is base A, B is equal to Y, so Y equals Y raised to the power A is B only. When both are E, the base is E and there is log base E, it's going to be 1. Alright, so let us differentiate this. So we have log E by 1 by x square, log E by x square. You can directly use log A minus log B here. In the denominator also you have log A into B, that is log E into x square. So when you have log E into x square, it will be log E, means log A plus B. So we can just separate them out, log A plus log B. In the first one, log A by B is log A minus B, log A plus B is log A plus log B. So we have here log E, that is log base E. So you can write it as 1, and log x square, so 2 will come in front. You know always log x to the power m is m log x, that is power always come in front. So we have 1 plus 2 log x. In this case, we have already taken this 1 plus 2 log x, and that is going to be in the denominator. In the numerator, it is going to be 1 minus 2 log x. So 1 log A minus log B, as I told you earlier also, log A minus B. So log that is the base is E and it is 1 minus log x squared. So 2 will come in front. Okay, I hope you got the idea. Log, this is the only thing which you need to understand in this. There is one thing which is this one. Second thing is the tan inverse A plus tan inverse B formula. So y is equal to tan inverse. We have here 1 minus 2 log x. Denominator we have 1 plus 2 log x. And tan inverse is there. So tan inverse 3 plus 2 log x. And divided by 1 minus 6 log x. So tan inverse A plus tan inverse B. Tan inverse A plus tan inverse B is equal to tan inverse A plus B divided by 1 minus A into B. What is A here is whatever is inside the first one tan inverse, and B is whatever inside the second tan inverse x. So just assume it to be A. So 1 minus 2 log x divided by 1 plus 2 log x plus 3 plus 2 log x divided by 1 minus 6 log x. So log A plus B. So this is tan inverse A plus B by 1 minus A into B. So we have 1 minus, multiply these two terms, 1 minus A into B. So 1 minus 2 log x by 1 plus 2 log x multiplied by same thing, 3 plus 2 log x divided by 1 minus 6 log x. Now you just have to take the LCM. You have to solve everything here. So I'm taking the numerator right now. Numerator. So just cross multiply, write it with the plus, and then multiply the denominator and write it in the denominator. That is how we do it if we don't know how to take the LCM. So 1 minus 2 log x into 1 minus 6 log x. I'm writing log x in short, plus 1 plus 2 log x into 3 plus 2 log x divided by 1 plus 2 log x into 1 minus 6 log x. This is only the numerator I am doing, remember. So the denominator will get cancelled. You will just see. I am writing the denominator now. Same thing. Multiply these two, put it here. So 1 plus 2 log x into 1 minus 6 log x here. So 1 plus 2 log x into 1 minus 6 log x, and then we have this one 1 minus 2 log x into 3 plus 2 log x. So just cross multiply, write with a negative sign, that is 1 minus 2 log x into 3 plus 2 log x. In the denominator you have 1 plus 2 log x into 1 minus 6 log x, and you multiply it by 1. Write it here. So this is 1 plus 2 log x. I'm just writing log x as L. Now denominator, you can cancel these two out. Now you have to multiply everything. I hope you'll be able to do. We are short of space. So just multiply everything. 1 minus 2 log x into 1 minus 6 log x. I'll show you one of it. These all have to be multiplied. So let us see what do we get. 1 minus 2 log x into 1 minus 6 log x. What do we get? So when we multiply this 1 minus 2 log x, it will be 1 minus 6 log x minus 2 log x plus 12 log x. So log x square will be there. So essentially you will get 1 minus 8 log x plus 12 log square x. So from here to here, this is the first one. Second you multiply, you will get this one. And this one you have to multiply the same thing which I just showed you. You will get this is in the denominator. Then you have 1 minus 2 log x into 3 plus 2 log x. When you multiply this, you will get. And these are quite easy. I mean, when you will see, there will be a cancellation. In numerator, in denominator. There are only certain terms that will be left. So 12 plus 4 is 16. This minus 8 log x plus 8 log x gets cancelled. You have 4 plus 16 into log x whole square. Denominator also, you have this 4 log x and 4 log x gets cancelled. 4 minus 12 is minus 8, so minus 8 log x whole square. 1 minus 3 is negative 2. So numerator, numerator I am taking 4 common. Denominator, you have to take negative 2 outside. So 1 plus 4 log x whole square, 1 plus 4 log x you will get in the numerator and denominator. You can just cancel them out. So when you cancel them out, you will get 4 by minus 2, that is minus 2. So tan inverse minus 2 will be there. So y is equal to tan inverse minus 2. Okay. Now since you have to find out dy by dx, we have just solved the expression. We have not differentiated as of now. So when you differentiate it, you'll see that tan inverse minus 2 is a constant. It will be a 0. When you double differentiate it, it will again be 0. So the answer will be 0. After all these effort, dy by dx is going to be 0. Let fx be a polynomial, then the second order derivative of f e to the power x. So double differentiation you have to do. So f e x, f, so y is f e to the power x. So dy by dx is f dash e to the power x, and differentiation of e to the power x will be e to the power x. Now d2y by dx2 is going to be f dash ex, e to the power x will be e to the power x, plus e to the power x, f dash e to the power x will be f double dash e to the power x. Alright? But you will not stop here. You have to do inside that e to the power x is there. So you have to differentiate that also. So when you do this, you see that this is going to be the final solution, and e to the power, this is the first term, and e to the power x and e to the power x, when you add the power, it will be e to the power 2x. So f double dash e to the power x, e to the power 2x will be the second term. First term you already know. It is e to the power x, f dash e to the power x. Now y is a cos log x plus b sin log x. You have to find out, or then x square y2 plus xy1. So y2 is d2y by dx2, y1 is dy by dx. So we have to do the both of these, but this y is going to come again back. So there is no trick here. Just this a cos log x and b sin log x will come up somewhere, and what you have differentiated, that may also come up. The first differentiation that may come up. So y is equal to a cos log x, and then we have b sin log x. So y1, that is dy by dx. So minus a cos log x is minus sin log x is 1 by x, plus b sin log x is cos log x. Differentiation of log x will be 1 by x. Now what you can do here is, you can differentiate it separately, or you can differentiate them together also. It's up to you. So you can combine this x and then differentiate. So let us do this. In the p by q form also you can do this. So y1 is this. See, there are different terms and there are different ways to do the same thing, as I have been telling in the previous discussion also. y2, that is the double differentiation where we are doing. This minus a is constant, sin log x by x. So I'll do it separately and then we'll combine it. So we have sin log x divided by x. So differentiation, denominator will be x square. P by q form we are following. We have x square. We have x sin log x minus sin log x. See, this sin log x differentiation will be cos log x, and log x differentiation will be 1 by x, minus sin log x was already done. Differentiation of x will be 1 only. So we have cos log x minus sin log x divided by x square. This is the first differentiation, that is the differentiation of sin log x divided by x. B plus b. Now cos log x divided by x, I'll do it here. Again x square in the denominator, x I'm writing like this. Cos log x is minus sin log x. Differentiation of log x will be 1 by x. Then we have minus cos log x is already done. Differentiation of x is going to be 1. So inside this you are going to get, I'm taking negative common from both these terms which we have just done. So x square in the denominator, you have sin log x plus cos log x. You can write like this. So we will combine these terms, and we'll try to find out why we have x square in the denominator. You can just get rid of this x square and take it into the left side, x square into y2 minus a cos log x. So I'm multiplying it first with minus. So minus will be plus. I'll just change the sign. So minus will be plus. And here both will be negative because negative is outside. So I'm just opening it up now. Minus b sin log x minus b cos log x. Okay. Now a cos log x plus b sin log x is what? A cos log x we already have, and b sin log x. So these two terms you can take negative outside. A cos log x plus b sin log x is y. You can replace it by y. Then we have a sin log x minus b cos log x. But you have already done y1 differentiation of first degree. You have already completed. Remember? So when you differentiate it, it will be minus a sin log x, remember, plus b cos log x. So if you take a negative outside, okay, and you already have this minus y term already was there. So I am taking these two, I am taking negative outside. So inside this you will get minus a sin log x. Here you have plus b cos log x. And this is nothing but y1. This is the first differentiation. This is x into y1. So minus y minus x into y1 is equal to, on the left hand side we already have x square y2. So x square y2, and you take this x y1 on the left hand side, only negative y will remain on the right hand side. So x square y2 plus x y1 is equal to negative y. This is minus y. Answer is negative y. Now x is 280, y is equal to 80 square. d2y by dx2 at x equals to half you have to find out. X is 280, y is 80 square, dx by dt is 2a, dy by dt is 280, dy by dx is dy by dt divided by dx by dt. So 280 divided by 2a, you can cancel 2a, 2a, t will come. d2y by dxt is dt by dx, because t differentiates, t is only remaining. dt by dx is reciprocal of 2a, 1 by 2a. At x equals to half, there is no x, so it will be half only. So this is the logic which I told you, and this is how you are going to do it. This is for reference because this is how you are going to write it. Now x is ft, y is equal to gt. d2y by dx2 you have to compute. d2y by dx2. So this 12.2 exercise we have already done, but for the sake of completion we'll do it. X is equal to ft, y is equal to gt. So dx by dt is equal to f dash t, dy by dt is equal to g dash t, dy by dx is dy by dt divided by dx by dt. So that's going to be g dash t divided by f dash t. d2y by dx2. Now you have some p by q form on the right hand side. So it's going to be f dash t whole square. I'm applying the p by q quotient rule. F dash t, g dash t is g double dash t minus g dash t. Now ft will be f dash t, f double dash t. Will not stop here because we are differentiating with respect to x, but only t is there on the right hand side. So dt by dx will also come. dx by dt is f dash t, so you can take the reciprocal and write it as 1 by f dash t. F dash t we already have square, so it will be f dash t whole cube in the denominator. So you just find out whichever is suiting your answer and just check it, because there are 4 options. That is the solution. Y is equal to sin m sin inverse x. Then 1 minus x square y2 minus x y1 is equal to. So this in previous exercises we have already completed this. For the sake of a completion, we'll attempt this. Y is sin m sin inverse x. So let us differentiate. dy by dx is sin is cos only. We'll call it as y1. Sin is cos m sin inverse x. Now differentiate m sin inverse x. So m is a constant. You can just write m. Sin inverse x is 1 by under root 1 minus x square. Alright. Now y2 differentiation will be done. That is first differentiation we have already completed. y2 differentiation, that is d2y by dx2 we have to do. So you can use the p by q form, you can use the p into q form, that is p can be cos m sin inverse, q can be 1 by under root 1 minus x square, that's up to you. So you can apply whichever approach you want. The result is going to be same. So what should we do? We can use the, and this constant we are going to take in later part. So under root 1 minus x square, I am applying the p by q quotient rule. Cos m sin inverse x is minus sin m sin inverse x, and differentiation of m sin inverse x is m 1 by under root 1 minus x square. There is a negative also that I'll just come up to. I have just missed a negative here. And this will be cos m sin inverse x, and differentiation of under root 1 minus x square, that will be done. So we've just seen a question. It will be negative x by under root 1 minus x square. So negative becomes positive. Positive x by under root 1 minus x square. Under root 1 minus x square whole square. So this root you can cancel. Root you can cancel. So multiply everything with m, because m was outside already. So the first term is going to be m square. Now this under root 1 minus x square, under root 1 minus x square, you can just bring it down or you can just cancel these two. Whichever way it suits you, So you'll just see that because ultimately this under root 1 minus x square in the denominator is 1 minus x square, and that 1 minus x square has to go on the left because we have y2 into 1 minus x square in the question. So under root 1 minus x square has to go here. So I'm just taking this m square, the first term I'm taking. So we have m square under root 1 minus x square under root 1 minus x square because it was under root 1 minus x square whole square only. So m square, so we don't have m here, so we cannot take this. I'm just trying different stuff, okay? So we have this m into let us have whatever is inside. M sin inverse x under 1 minus x square plus x cos cos m sin inverse x. This is the inside term. Now this under root 1 minus x square under root 1 minus x square in the denominator, because this was under root 1 minus x square whole square. So I'm writing under root 1 minus x square whole square is under root 1 minus x square into under root 1 minus x square. These two under root will give you 1 minus x square. So y2, I'm taking this 1 minus x square on the left hand side. So y2 into 1 minus x square. Okay. So this has gone on the left. Only right hand side is left. So you have m sin inverse. Now I'm multiplying it. So m will be m square. So m square m minus sin inverse x divided by 1 minus x square, because as I told you, this under root 1 minus x square we have already taken outside. Now we have this mx cos m sin inverse x. So you have to have this one in the denominator because 1 under root 1 minus x square is still left with us. It got cancelled with the first term, but it has to come with the second term. But what is this? This is y1. This whole term, if I just forget x, other term, whatever we had is y1 only. So you can write it as plus x y1. Now y was already sin inverse x. So this term is y only. You have a m square y, but I told you that I missed the negative. So I have to, because first thing was cos m sin inverse x differentiation. It was negative sin m sin inverse x, remember? So this, the negative I missed, I'm going to put it here because cos theta differentiation is minus sin theta. So I'm now allowing it here, 1 minus x square into y2 minus ym square plus x y1. So just take this according to the question, just change the positions. 1 minus x square into y2 minus x y1 is equal to negative m square y. So this whole term, this question is asking what is on the right. It's going to be minus m square y. So your answer is this one, minus m square y. So as I told you, I took a different approach. You can take a different approach. It's up to you, whichever you want. I hope you got the idea. So this is how we complete this. If y is equal to sin inverse x to the power square, then 1 minus x square into y2 is equal to, y2 corresponds to d2y by dx2. So we have to do the double differentiation. And what are the options? One of them has to be true. So the exercise previously we have completed, we have already done this type of question. For the sake of completion, y is equal to sin inverse x to the power square. So dy by dx is going to be equal to, it is actually equal to y1 or y prime y dash. So 2 sin inverse x, and then differentiation of sin inverse x is going to be 1 by under root 1 minus x squared. Then the double differentiation. So we have sin inverse x divided by under root 1 minus x square. 2 I'll take later. So y2 we are going to do d2y by dx2 it is. So we will use the quotient rule, p by q form. So the denominator will be squared. It will be only 1 minus x square. And then we have under root 1 minus x square. Sin inverse x will be 1 by under root 1 minus x square. So this is sin inverse x. Minus sin inverse x will be like that only. And we'll do the differentiation of 1 by under root 1 minus x square. Since 1 by under root 1 minus x square have been discussed and done quite a lot for a while, so I'll directly write the result, negative x by under root 1 minus x square. This negative will become plus. So sin inverse x by under root n minus x square into x. This gets cancelled. 1 by under root 1 minus x square gets cancelled with under root 1 minus x square. Only 2 will remain because 2 was already outside and I have multiplied this inside. And this under root 1 minus x square is there. 1 minus x square is also there. And there is a 1 minus x square below the 2 also. Because when you multiply 2 with 1, it will be 2. And the denominator has 1 minus x square already. So just put this 1 minus x square in the denominator and we have 2 by 1 minus x square plus 2x into sin inverse x divided by under root 1 minus x square into 1 minus x square. So I am taking 1 minus x square everywhere for multiplication. So this y2 will come up with 1 minus x square. All the 1 minus x square in the denominator on the right hand side will get cancelled. So you have 2 plus 2 into x into sin inverse x by under root 1 minus x square. Now if you remember, y1 was 2 sin inverse x by under root 1 minus x square. We already have. If you exclude x from here, then the other thing will be y1. So essentially this is x into y1 only. So x into y1. y2 into 1 minus x square is equal to 2 plus y1x. So this is your answer. This is your final answer. Respective option you may choose. Y is equal to e tan x, then cos square x into y2. So for the reference I have provided the solution, but we'll do it, and most of the time the solution which I provide is different from the solution I give for reference. So let us see. There may be multiple ways to solve it, but the solution or the result has to come in one of the 4 options. So y is this one, dy by dx, that is y1 we are calling it, is e to the power tan x, and differentiation of tan x is going to be sec square x. Now y2, so we have 2 terms here. This is the first term, this is the second term. So this y1 we are going to reuse. So please remember, e raised 10x into sec square x will be reused just now. But we have to now do the product rule. E tan x to sec square x will be sec x, and then sec x differentiation will be sec x tan x. Then we have plus sec square x, and e tan x, e raised tan x will be e raised tan x only, and tan x will be sec square x. So this has already been done. So now this can be termed as y1, but not now. I'll just look for the first term also, then we'll do the changing or the replacement. Now this is sec square x. You can take the sec square x common from both the terms. What will be remaining? 2 tan x, e raised tan x, plus this will come outside. We have e tan x and sec square x. Now you might be tempted to ask that why are you not taking e raised tan x outside? Because e raised tan x into sec square x is already y1. Okay, and this e raised tan x into tan x, so we can just change this also, the first term also. I'll just show you. But whatever is required, this sec square x will go to cos square x when we transfer it on the left hand side. So because sec square x is essentially 1 by cos square x, and we cross multiply it is going to be cos square x by 2. This is going to be this plus e tan x into sec square x was already y1, as I showed you that we are going to reuse it. Now here we have to change certain things. See, only if I multiply this with sec square x and divide by sec square x, because sec square x into e raised tan x is y1. So I'm multiplying here the first term with sec square x in the numerator denominator. So when you do this, you'll see this whole term e raised tan x sec square x is what? Y1. You can replace it by y1. And what is remaining? 2 tan x into divided by sec square x. That we are going to do just now. So 2 sin tan x will be sine by cos, and cos square if it goes, sec square is if it goes up, it is cos square. So you can just cancel this. 2 sin theta cos theta, 2 sin theta cos theta is sine 2 theta. So it will be sine 2x. So you can write it as sine 2x. You have y2 cos square x is required on the left, so right will be y1 into 1 plus sine 2x that we have as an option C in this particular question. Next is y is equal to ax plus b divided by x squared plus c, then 2x y1 plus y into y3. y3, that is we are going to differentiate it thrice, 3 times, and we'll do the we'll follow the natural course of differentiation. Y is equal to ax plus b by x squared plus c, and the best thing to do is using the p by q form, that is the question form, but you may also do it with cross multiplication. That is, x square plus c can be brought on the left hand side with cross multiplication, and then ax plus b will remain on the right hand side, and now you can proceed with your differentiation in the form of p dot q, that is the product rule. So x square plus c we have, then we have dy by dx plus y will be there, x square plus c differentiation will be 2x, and this is going to be equal to what? This is going to be equal to ax plus b, and ax plus b differentiation is only a. So this is y1 differentiation is dy by dx, so we may reuse the content in the later part. And this x square plus c into dy by dx differentiation, dy by dx you can write it as 1, it will be easier for the later part. Okay, left hand side, x square plus c. So x square plus c dy by dx will be d2y by dx2 plus dy by dx, and x square plus c differentiation will be 2x plus. Now we have 2y into 2x, so you can have 2xy. Now we are differentiating x and y. Remember, we are differentiating with respect to d by dx, that is with respect to x. So xy differentiation will be what? 2 will remain there, we'll use it later. Differentiation of x by x, this dy by dx plus y, d by dx of x is 1. So we have x into y1 plus y. So just multiply with 2. You have 2y plus 2x dy by dx. So 2y x square plus c d2y by dx2 can be written as y2 plus 2x dy by dx can be written as y1. Then we have 2y we have already written on the first term, and we have 2x dy by dx. This already done. 2x dy by dx you can write it as 2x into y1. 2x into y1, and everything on the right hand side is 0 because differentiation of a we have already done and it is 0. So we have a 0 here. This has come. This is an expansion. Now just add these two whichever are possible. 2y into x square plus c into y2, and 2x y1 plus 2x y1 is 4x y1. Okay. Now since it is asking for y3, so we have to differentiate it again. 2y differentiation y1. Now 4 into x y1. Differentiation of x y1 will be what? X y1. So x y1 will be y2 plus y1, and differentiation of x will be 1. So you can write it as 4x y2 plus y1. Now again here this can be done in p dot q form, product rule. So I'm doing it here. X square plus c, y2 differentiation will be y3. Then we have y2, and differentiation of x square plus c will be 2x. This will be 2x y2 and then y3 into x square plus c, and that is going to be equal to 0. Okay, let's open it. 2y1, it's not y, 2y1. 4x y2 plus 4y1 plus 2x y2 plus y3 into x square plus c. Okay, remember we are going to replace certain thing, as I told you that this x square plus c has to be eliminated in the terms of y and x, or y, y1, y2, y3x. So 4x y2 plus 2x y2 is 6x y2, 4y1 plus 2y1 is 6y1, and it is okay. Now this y3 into x square plus c. X square plus c can be computed or can be replaced by what we have done earlier, because we are requiring with y3 in the question 2x y1 plus y, from where we are going to get this y3. X square plus c, there is a step which we just have seen, that 2y plus 4x y1 plus x square plus c into y2 is equal to 0, and from here we can eliminate this x square plus c with the terms having y, y1 and y2 and x. So this particular line, this particular step, it will be used for the replacement. How we are going to use the replacement? See, x square plus c, 2y here. So you can just x square plus c into y2, you can just take minus 2 on the right hand side, minus 4x y1 on the right hand side, and y2 in the denominator. Now you can replace the x square plus c as minus 2y minus 4x y1 by y2. So I'm replacing this by minus 2y minus 4x y1 into y2 is equal to 0, right? Now we have come up with a certain, because 2x y1 plus y into y3 we have got, but there are still things remaining because this is 2y minus 4x y1. So what to do is, this y2 has already gone. This 2y multiplied by y3. Okay, y3 is already there. You don't have to multiply, but it is still there. But you can do one thing. You can just multiply this and then do it later, because we are going to divide it by 2, because we don't need this minus 2y1 minus 4x1, or you can say 2y plus 4xy1. We need 2xy1 plus y. We need 2xy1 plus y. So let us divide 2 with everything. When you divide 2 with everything, I'm taking just this 2y minus 2y minus 4x y1 y3 I can take on the right hand side. When I take it on the right hand side, it will be pretty easy for me to divide everything by 2, and when we divide it by 2, you will get on the right hand side 2x y1 plus y into y3, which is intended in the question. So I'm just dividing everything by 2. So it will be 3y1, 3y1 y2, 3x y2 square, and since here this is what is required, so you can divide it by 2 and taking on the right hand side as I just suggested. So it will be y3 on the outside, it will be y plus 2x y1. Now y plus 2x y1 into y3 is being required in the question, and that is, if you take the left hand side of this, you can take 3y2 common here. You have y2 here, you can take just 3y2 common, and when you take 3y2 common, you will see that it's going to be 2x y1 plus y into y3. Okay, so this is going to be your result, 3y2 into y1 plus xy2. So I'm just taking things common. You know it very well, because it's just taking common and making it relate to the options being given in the question. So 2xy1 plus y into y3 is essentially equal to the option A, which is y1 plus xy2 into 3y2, and that is going to be your answer. That is what you are going to tick or choose in these multiple choice questions, right? Now this y is equal to log x by a plus bx to the power x. Now this power x will certainly come in the front, okay, because it is y log x. It's y is equal to x log x by a plus bx. Let us differentiate it. Dy by dx is going to be equal to, see, this is y1. You can write it as y1. This is going to be equal to log x by a plus bx. Differentiation of x will be 1 and plus, now x will be there. Now we'll differentiate log x by a plus bx. So the 1 by of this is reciprocal of this, a plus bx by x, and differentiation of x by a plus bx, this is going to be a plus bx whole square. It is going to be, then we have a plus bx here, differentiation of x will be 1. Now minus x here, and a plus bx differentiation is going to be b only. So numerator is going to give you in this step, let me write it everything first. Log x by a plus bx, and x get cancelled with this. 1 a plus bx gets cancelled. A plus bx minus bx is going to be bx gets cancelled. You have a plus a by a plus bx. This is your y1. For the reference, I am just giving you the solution. This y1 we have already achieved. Now this is your 1. Now a by a plus bx is going to reappear. So we need to replace it. So let us do it here only. If in this log x by a plus bx, if I multiply x and divide by x, then x into log x by a plus bx will be what? It will be y. So this whole is going to be, why I'm introducing x in the numerator denominator, then only it will come. So it will be y by x plus a by a plus bx. On the left hand side you have a y1. Now take this y by x on the left hand side. y1 minus y by x is equal to a by a plus bx. So y1 minus y by x is equal to a by a plus bx. We are going to utilize in the later part. So you can call it as whichever number you want, but this is going to be utilized in a short while. Now y1 was already done. This one, y1 was already done. Now we are going to differentiate this y1. Okay, we are going to differentiate y1, which is equal to log x by a plus bx plus a by a plus bx, which we actually got. X by x, which we introduced, we are not going to use that. That was only done to tell you, to show you that a by a plus bx has to be replaced by x, y1 minus y by x, and how has it come. That is the only thing which we have done. So this differentiation we have already done, log x by a plus bx. If you remember, while we were doing the product rule for x into log x by a plus bx. Okay. So let us differentiate this y1, which is log x by a plus bx. It is going to be a plus bx by x, a plus bx by x, and in the numerator only a, and denominator we have a plus bx. Remember, a plus bx, so we can just cancel this out. And then we have in this a by x into a plus bx. Now we have done this differentiation. Now this differentiation will be done. Since it is a constant, you can just write a like that. I'm not writing this sign because definitely it is going to be negative, because we are going to differentiate 1 by a plus bx. A plus bx will go in the numerator, a plus bx to the power negative 1, negative. So when you differentiate, negative will come in the numerator, minus a plus bx minus 2. A plus bx differentiation will be b. So it will be minus a, we have a plus bx to the power square. This b will come here. Okay, now so we'll take the LCM first and we'll try to resolve it so that we come up to a by a plus bx, which we did already. So I'm taking the LCM. It's going to be a into a plus bx in the numerator for the first term, and it's not a plus b, it's a plus b bx. Sometimes I just forget certain things, and if you're following, you know that what we are doing right. Minus abx. So we have just multiply this, a square plus abx. We already have a minus abx. You can cancel these out, only a square will remain. So what do we get here? We get y2 is equal to, we have a square by x into a plus bx whole square. Now if you remember, a by a plus bx whole square is x y1 minus y by x. I told you that this is going to reappear. We actually did certain things to make it appear. So a by a plus bx can be replaced by x y1 minus y by x. Since it is square, we are replacing it by square. So x y1 minus y by x whole square it will be, and you have a denominator in the x, so you can write it as x y1 minus y whole square by x cube, because x square was already there, x was there, so we have Now x3 take on the left hand side. It is going to be x cube, x3 is x cube into y2. That is what is asked in the question, and this is equal to x y1 minus y whole square. Remember? So x y1 minus y whole square is x cube into y2. We did everything to get x cube and y2 on the left hand side, and whatever comes on the right hand side, that is going to be your answer. It can be x y1 minus y whole square. It can be y minus x y1 whole square, because it is square essentially. Now we have x equals to f t cos t minus f dash t sin t. So we have functions only here, and then y is also given, and we have to find out this. So we have already done part of these questions already in our previous discussions. So let us see how we go about it. So just differentiate it and just put it in the formula being given, dx by dt whole square, dy by dt whole square. So let us start. X is equal to ft cos t minus f dash t and sin t. So dx by dt will be, there are two functions here. In the first term, two functions. Second term also two parts. Means two terms, and in every term we have two functions here. So we'll take this term first, ft. I'm applying the product rules. So cos t will be minus sin t. Then we have cos t, and differentiation of ft will be f dash t. Then we have the second part, or you can say second term, and it has two functions. So it will be under the negative. So f dash t will be like this, sin t will be cos t, then plus sin t will remain like that, and f dash t will become f double dash t. So because the differentiation is f double dash t. Now let us open this. Dx by dt will be, there will be certain cancellation here. Minus ft sin t plus cos t f dash t minus f dash t cos t minus sin t f double dash t. So what is the cancellation here? See, f double dash there is nothing. So we have the cancellation will be done for these two. The middle part. Okay, so what will be the final thing? Minus ft sin t minus f double dash t sin t. Now same way we have to find out the second one, dy by dt. So same thing we have to do, ft cos t minus f double dash t cos t. Now we just have to square them. dy by dt will be the final one. Okay, I am not doing it. I just told you that dy by dt will be done in the same terms, and there will be a cancellation, and final things will be here, and we have to just square it. And since we have a negative for the first term dx by dt, we have just taken the negative out and squared it, so it will be plus only. So we just have to add them, ft f double dash t with sin t, and here also in the second term dy by dt we have cos t terms. So when you square this, sin square will come. So I'm just taking sin square t outside, and the first term I'm taking f dash t, this I'm not doing anything, I'm just squaring it. It is not whole square. So ft plus f double dash t, just make it as square. I'm just taking sin square out because we know sin t is in both the terms. In the second one we have cos square t I'm taking outside. So we have ft plus f double dash t. So these are the two things which are common here. So we can take this common outside, ft plus f double dash t. When you take this out, what will be inside? Sin square t plus cos square t inside. And you know that sin square t plus cos square t is 1. Means sin square theta plus cos square theta is 1. So ft plus f double dash t whole square will come. This is your option. Option C is the correct answer. Now here you have to see, because there are certain things which will be in between, and that will be used in the later part. Alright. So there are certain steps which will be used for the later steps. So we have y raised 1 by n plus y raised minus 1 by n negative 1 by n. This is equal to 2x. Now we have to differentiate this. Please remember, x to the power n differentiation is n x to the power n minus 1. So 1 by n, y to the power 1 by n minus 1. Then you have this negative 1 by n comes in front, y to the power minus 1 by n minus 1, these two. Differentiation of 2x will be 2. So what are we going to get here? Can we make it simpler? Because we have to keep an eye on what is being expected also. X square minus 1 into y2 plus x y1, this is being asked. So this, we have just done one part, because once you differentiate y to the power 1 by n, it will be 1 by n, y to the power 1 by n minus 1. But what about y? There will be dy by dx also in both the terms. So I have to introduce or include y1 also. So this y1, so we'll take y1 outside. y1 is simply the differentiation. 1 by n also we can take out. y1 in the numerator and in the denominator. So y1 by n it is. Now y to the power 1 by n minus 1. And since y to the power 1 by n minus 1 can be written as y to the power 1 by n into y to the power minus 1. Here also y to the power minus 1 by n here, and y to the power minus 1. So we can see that y raised minus 1 is nothing but 1 by y. So that can be taken in the denominator. You just assume that y raised minus 1 is 1 by y. Y can be taken outside. So what we took outside y1 divided by ny, and there are two terms which are inside, y raised 1 by n minus y raised minus 1 by n. So this will remain inside, and other terms can be whatever is in the denominator you can take to the numerator of the other side. So n into y I am taking on the right hand side, it is 2ny. So this we are going to reuse. I mean we are going to replace somewhere. So what we have got up till now is y raised 1 by n minus y raised minus 1 by n into y1 is equal to 2ny. Alright, now let us differentiate this, because there is y2 in the question, so we have to differentiate it again. So I am applying the product rule. The first one is like that, then y1 will become y2. Now y1 will remain like that, and y raised 1 by n minus y raised minus 1 by n we have already differentiated with a positive sign. Same thing will be happening here with a negative sign in between. But when we differentiate this, we know that the second part of y raised minus 1 by 1 there will be plus in between, because negative will come, because minus 1 by 1 will come in front. And this is going to be 2n, and differentiate, because 2n is constant, only differentiation of y will be done, that is y1. So this n is in the denominator. Why don't we multiply everything with n? Because we want to just eliminate this n in the denominator. Alright, and y raised 1 by n minus 1 or y raised minus 1 by n minus 1, in the previous step, just few seconds back, I told you y raised minus 1 can be written as 1 by y. So we have n from the denominator, y again from the denominator, that is y raised minus 1. So we have this ny in the denominator. So what do we get? I am multiplying now. Okay, multiplying everything with ny. So the first term will be multiplied by ny, so it will be ny y2 whatever is inside. Then we have y1 square, because ny is already being multiplied. On the right hand side we have 2n y1, and ny is to be multiplied. 2n y1 is there. We have to multiply it by ny, so it will be 2n square y by 1. Now what do we see here? As I told, we are going to use it. So why don't we divide everything with y1? We are dividing everything with y1. This is not y, this is y1. This gets cancelled. Here 2ny is there. So in order to bring this, if I bring this y1 in this particular step, 2ny by y1, and we already have ny by y1. So in place of ny by y1, I can write or replace it by y raised 1 by n minus y raised minus 1 by n divided by 2. This is already there. Y 1 by n minus y raised minus 1 by n. So we have replaced this y raised 1 by n minus y raised minus 1 by n into y1 equals 2ny in this step. Rest thing remains like that. y1 was there, this term with plus sign, and on the right hand side already y1 is eliminated now. So these are two things similar, so we can just square it. Y raised 1 by n minus y raised 1 by 1 whole square. This is y2 by 2. Now see, we have a minus b whole square can be written as a plus b whole square minus 4. A minus b whole square will be equal to a plus b whole square minus 4. This y raised 1 by n minus y raised 1 by minus 1 by n square is nothing but y raised 1 by n plus y raised minus 1 by 1 minus 4. So I am replacing this term with the formula which I just gave you with this thing. Okay, alright. So let us see this. A plus b whole square, that is the y raised 1 by n plus y raised minus 1 by 1 is already with us. It is 2x, and 2x whole square is going to be 4x square. So this whole, by the formula I just introduced, this can be written as 2x square, that is 4x square. So this is 4x square minus 1, which I got just now, and then we have other things remaining. I'm just writing like that. Okay, all other things are there. So just this 2 can be replaced. We already have x square minus 1 now with a y2. So just divide everything by 2. I'm cancelling 2. X square minus 1 into y2 is there. We have x y1, and on the right hand side we have x square y. Oh, n square y, sorry. So on the right hand side we have n square y. This is the answer. Okay, I hope you got the idea. This is the step which is the trick. A minus b whole square is a plus b whole square minus 4. Now we have d by dx of this term. This is a series multiplied by e to the power x is equal to x raised n e to the power x. Now we have to tell the value of AR. AR is what? A1, then we have A2, A3. So what will be AR? If we are able to find out A1, A2 and A3, then we can form a pattern or a series. So the d by dx is of two terms. First is the series, and second is e raised x. I am writing one as p, writing other thing as q. So p multiplied by q. So we have to follow the product rule. So e to the power x differentiation. Let us take this e to the power x, and the inside content will be see. First I am differentiating e to the power x. So the p term which I designated will come as it is like that. So I am writing the series as it is. Only differentiated e to the power x, which eventually comes to e to the power x only. Then we have plus. Now e to the power x will remain like that, and now I am differentiating the p term. which is nx to the power n minus 1. X to the power n differentiation is like this, minus a1, differentiation of x to the power minus n minus 1 is n minus 1, x to the power n minus 1 minus 1, that is n minus 2. Then we have plus. I'm not writing whole of the term because you will be able to know that there is a pattern which is being followed, right? So I hope you will be able to differentiate all of this. So you need to know the binomial theorem and binomial stuff, because this is what is being applied here. So I'm taking this e to the power x common from both the terms. So inside it will be x to the power n. Now I am taking x to the power n minus 1 common. So what is being inside? N minus a1. Then we have x to the power n minus 2. And what do we have inside? a2 minus a1 into n minus 1. So I am just taking e to the power x outside, other things with the term similar, that is the power of x, wherever it is similar, I am combining those terms. That is the only thing which I am doing right now. So we have x raised n, x raised n minus 1, then x raised n minus 2. So there will be multiple terms here, and you will know what will be the final term. Now this is equal to x to the power n e to the power x. Alright, now just equate this. So x to the power n e to the power x is already there. So all the other terms are going to be 0. That is x to the power n minus 1, there is no coefficient here. X to the power n minus 2, no coefficient here. So n minus a1 is equal to 0. Similarly here a2 minus a1 into n minus 1 is equal to 0. So the first term gives a1 equal to n. The second term just replace a1 by n. So you'll get a2 as a1 into n minus 1. So a1 is this, a2 is this. When you do the a3 term, it will be n minus 1, n minus 2. I'm not doing it in the short form because you know already, if you are aware of the binomial, then this is quite simple for you. Then we have an will be n minus 1, n minus r minus 1. That will be the final term or rth term. So this n minus 1, n minus 2, it goes up to n minus r minus 1, and this is going to be equal to ar. So the ar term or the rth term between 0 and n, if r is belonging, then ar is going to be n minus 1, n minus 2, and this goes up to n minus r minus 1, and this is nothing but factorial n by factorial n minus r. Alright, so this is the C option is the correct option. Next is y is equal to x to the power n minus 1 log x, then x square into y2 plus 3 minus 2n into x y1 is equal to. So those who have already done a lot of questions and they are comfortable, they can go ahead with the reference I have provided. Those who want to follow, let us solve it. Y is equal to x raised n minus 1 log x. So y1, the first term is x raised n minus 1, the second term is log x. So let it be p into q form. We are going to apply the product rule. So log x is 1 by x plus log x will remain like that. X raised n minus 1 differentiation is n minus 1 into x to the power n minus 2. So I am taking x in the denominator now. So here it will be x to the power n minus 1 plus log x n minus 1 x to the power n minus 1. So there will be x. So x n minus 2 into x to the power 1. This is y1. We wanted x y1. So let us multiply both sides by x. So you'll get x y1. One term we have got. So this is going to be equal to x. See, x raised to the power n minus 1 into log x is already y. So we can replace it here. This x raised to the power minus 1 and log x can be replaced by y. Alright. So this is going to be x to the power n minus 1 plus n minus 1 into this whole I am replacing it by y. Okay. So we have x, y1 will be y2 plus y1. Differentiation of x will be 1. So n minus 1, x to the power n minus 1 will be n minus 1, x to the power n minus 2. Then constant is n minus 1. Differentiation is y, differentiation of y is y1. Okay. So this is xy2 and we need this 3 minus 2n terms. So how are we going to get this? Let us see. N minus 1 into x to the power n minus 2. So x to the power n minus 2 can be written as x to the power n minus 1 into x to the power minus 1. When you add this, it's going to be n minus 2 in the power. So I'm writing this x to the power n minus 2 as x to the power n minus 1 divided by x. I hope you got the idea. Now you see that we need x square y2. We need all the term which is on the right. So x square y2. I'm multiplying everything with x now. X square y2 plus x y1 is equal to x to the power n minus 1, and this x will go, this is n minus 1 into plus n minus 1 into y1 into x, because we have multiplied it by x. So this we got this x raised n minus 1, n minus 1 into y1 dot x. So x raised n minus 1. So we have to write certain thing which we have already done. We have to replace it because there is no x raised n minus 1 in the final answer. or x raised n minus 1 will take it from here, this particular step. So x raised n minus 1 can be, because n minus 1 into y can be taken on one side, so x raised n minus 1 can be written as xy1 minus n minus 1 into y. So x square y2 plus xy1 will be equal to xy1 minus n minus 1 into y. N minus 1 is already there, and then we have x into y1 into n minus 1. I hope you have a better understanding now. So x square y2 plus xy1 is equal to xy1 into n minus 1 minus n minus 1 whole square into y x y1 into n minus 1. Now they are similar terms, so you can just add them up. It will be twice of x y1 into n minus 1. Now take this on the left hand side, x square y2 plus x y1 minus 2x into n minus 1 into y1. This is going to be equal to negative n minus 1 whole square into y. What do we want? X square y2 plus 3 in minus 2n into xy1. So 3 minus 2n, how are we going to get? Okay, this is the basic thing. Now this is xy1, this is xy1, they both have xy1 term, they both have xy1. So xy1 minus 2xy1 n minus 1 xy1, you can just take common, it will be 1 minus n 2 twice of n minus 1, and this is going to be xy1 1 minus 2n minus plus 2. So this is 3 minus 2n, and that is what we wanted. 3 minus 2n, 1 2n has come. X square y2 plus 3 minus 2n into xy1 is equal to negative n minus 1 whole square into y. This is your final option. Xy minus log y is equal to 1 satisfies equation this. You have to find out the value of lambda, because on the left what is being sought is a lambda, which is a constant, and lambda has to be computed. So what do we have? Xy minus log y is equal to 1. So we have xy minus log y. So we have y1 also and we have y2 also. So simply we have to differentiate it twice, y1 and y2. So x, first term, x, y1, then we have y. Differentiation of x will be 1 only. Log y is 1 by y, and differentiation of y will be dy by dx. You can write it as y1, and this is going to be 0. Now multiply everything with y. So x y1 into y plus y square minus y1 is equal to 0. So we have to differentiate it again, because we need lambda. There will be certain term with y1 that is going to come for sure. So since we have y2 also, we have to differentiate it now again. And since we have two terms here, x y1 into y, three terms actually. So we have to differentiate with respect to or following the product rule, taking two at a time. Means one differentiation, two will not be touched. So I am doing the second and third term first. Y square is 2y, then differentiation of y is y1. y1 differentiation is y2. Now doing x y1 y. Now x y1 will remain there, whereas differentiation of y will be y1. Now let us take y1 and y untouched, and differentiation of x will be 1. Now let us take x y here, and differentiation of y1 will be going to be y2, and this is going to be equal to 0. Now take those terms which are similar, we can add them. So we have 2y y1 and we have y y1 also. This y1 will be y1 square. This is x y y2. So we have x y1 square plus y y2 minus y2, and 2y y1 and y y1 will become 3y y1 is equal to 0. Now just equate this with the equation being provided to us. When you equate this, lambda is going to be 3. So what is the value of lambda? It's 3. Y square is ax square plus bx plus c. Then we have to find out y cube d2y by dx 3. Whether it is a constant, well, let me tell you in advance, it is a constant, how it is going to come. So y square is equal to ax square plus bx plus c. Now this y square term we are going to replace. We'll just find a better place to replace it. Let us differentiate it. It is 2y dy by dx is equal to y square differentiation is 2y dy by dx. On the right we have ax square, so it will be 2ax, bx will be b, and c will be 0. One more differentiation, 2 will be outside, so y d2y by dx2 plus then 2 dy by dx. Differentiation of dy by dx will again be dy by dx, so it will be dy by dx whole square, and this is going to be equal to b will be 0, 2ax will be 2a only. So what is 2 doing here? Let us eliminate all of it by dividing it by 2. So we have y d2y by dx2 plus dy by dx whole square equals a. Now we are still not done, because we need d2y by dx2 with y cube. So dy by dx we have already done, and dy by dx whole square we want. So this can be replaced. Dy by dx was what? In the second step. Dy by dx can be written as 2ax by b by 2y. So I am replacing now dy by dx as 2ax plus b by 2y, or 2 gets cancelled, sorry. So we have y d2y by dx2 plus, just square it, 2ax plus b by 2y whole square. This is going to be 4y square, and right hand side is going to be, I'm just replacing, not differentiating. So let us multiply everything with 4y square. So y into 4y square is 4y cube dy by dx2 plus 2ax plus b whole square. This will be eliminated. On the right we are going to get 4y square we have multiplied, and a is already there. So 4ay square. So 4y cube. So we need this 4 to be eliminated somewhere. So let us see what are we going to get. Let us bring this on the right hand side. 2ax plus b square on the right hand side. So 4ay square. Oh, here y square can be replaced. As I told you, y square will be replaced somewhere. Y square can be replaced as ax square plus bx plus c here. So you get 4y cube d2y by dx2 is equal to 4ay square. In place of y square, I'm replacing it by ax square plus bx plus c. On the right, it is 2ax plus b whole square subtracted. Now, this is divided by 4. So when you resolve this, 2ax plus b whole square is 4a square x square plus b square plus 4axb. I'm not writing it. I'm just telling you that there will be an opening and there will be a cancellation. 4a square x square will be cancelled and 4abx will be cancelled. Only 4ac minus b square by 4 will remain. I'll just show it to you here. When you open this, a plus b whole square, when you multiply this, what terms will be get cancelled? 4ac and b square will remain. 4a square x square will get cancelled. 4axb gets cancelled. So on the right you will have 4ac minus b square by 4. This is all constant. There is no x and y. So this is a constant term. What is the option we got? The first option is a constant, and that is going to be your answer. Okay, this is all about this exercise. Thank you so much and take care of yourself.